Hi, welcome to mean, median, mode, variance, and standard deviation. In this video, we're going to look at calculating some basic quantities based on a data set. We'll be looking at the mean, median, mode, variance, and standard deviation of a toy set of data. In other videos, we'll be wanting to calculate, for example, the mean and standard deviation of the Poisson distribution. So we'll set up the calculations here on the toy dataset the same way we will later with more complicated calculations. So even if you already know what a mean and standard deviation are, this video might still be useful to you. For our toy dataset, we'll imagine that there is some sports team that keeps track of how many points they score in each game over a season. They play a total of 34 games in the season. They score between 0 and 5 points in each game. They make a table and a plot of how often they score 0, 1, 2, all the way up to 5 points in a game. Okay, so here's what their data look like. We have a table and we have a plot. So there were, for example, 3 games in which they scored 0 points. There were 6 games in which they scored 1 point per game. There were 7 games in which they scored 2 points, etc. So let's start by calculating the mode of the team's score. Okay, so the mode is the value of the variable that occurs the most often in the dataset. From the plot, we can see that the most common value of the score was 5, so the mode is 5. Okay, so next we'll look at the mean, also called the average. The mean gives a typical value for your set of numbers. To take the mean of a set of numbers, you add them up and divide by how many numbers you're averaging. So if you're averaging n numbers, x1, x2, all the way up to xn, the mean, which we'll denote as x in brackets, is 1 over n times the sum x1 plus x2 plus x3 all the way up to xn. So for example, if you wanted the average of the 5 numbers 7, 13, 12, 15, and 8, you would compute 7 plus 13 plus 12 plus 15 plus 8, which adds up to 55, and you would divide by 5, which is the number of numbers that you're averaging, and you would get 11. Okay, so now let's do this for our toy dataset. Okay, so now let's do the same thing to get the team's mean score. We sum up the team's scores from each of the games and divide by the number of games, which was 34. So the mean score equals 1 over 34 times the sum over I, from 1 to 34, of score sub I. Now here, I represents which game we're talking about. So for example, score sub 5 is the team's score from the 5th game. Okay, so let's take a look at that table and write this a little differently. Let's call the number of games where the team had a certain score f of score. So for example, f of 0 equals 3 because there were 3 games in which the team had a score of 0. F of 1 equals 6 because there were 6 games in which the team had a score of 1. And f of 2 equals 7 because there were 7 games in which the team had a score of 2. Now, note that f of score is the same quantity that we had before in our table and in our plot. Okay, so let's look at our expression for the mean of the score. So here, the mean of the score was equal to 1 over 34 times the sum of all of the scores from all of the games. The sum in this expression has 34 terms in it. 3 of these terms have the score as 0, 6 are where the score is 1, etc. So for each value of the score, there are f of score terms. Okay, so we can rewrite the expression for the mean in the following manner. So originally we wrote that the mean of the score was 1 over 34 times the sum over all of the 34 games of the score for each game. Now let's rewrite that as 1 over 34 times the sum over the score from 0 to 5 of the score times f score, which is the number of games in which that particular value of score was obtained. So note that the sum over score from 0 to 5 of F score equals 34. So we've effectively taken the 34 terms from the top line and regrouped them in the bottom line according to the value of score. Okay, so now let's actually calculate the mean. Here's our expression for the mean score, and now let's substitute in our values of score and F score from our table. Okay, so for example, for the first term in the sum, there were 3 games in which the team had a score of 0, so we get a 3 times 0 for the first term in the sum. Okay, we repeat that for all of the terms in the sum, and we get that the mean score is equal to 98 over 34, which is about 2.88. Okay, so let's mention one more thing about computing a mean. Perhaps we would like to compute the mean of some function of the score, like score squared, or 3 score squared minus 5 score. We can do this by plugging the thing that we want the average of into the same equation. So for example, if we wanted the mean of score squared, we would write down the same sum as we had before, except now the terms, instead of being f of score times score, would be f of score times score squared. And if we wanted the mean of score cubed, we would again write down the same sum, but we would have f of score times score cubed. Okay, so now that we know how to calculate the mean of a function, let's look at the variance of a set of numbers. So the variance of a set of numbers x1, x2, etc. up to xn is the mean of the square of the difference between those numbers and their mean. So here we've written out the variance of x equals 1 over n times the sum from I equals 1 to n of the square of the difference between xi and the mean of all of the x's. So note here that x in brackets is just the mean of x, which is just a number and which we already know how to calculate. Okay, so let's write that out for our case. If we computed the variance by summing over the 34 games, we would write that out as follows. The variance of the score is equal to 1 over 34 times a sum over the 34 games of the square of the difference between the score from a particular game and the mean score. Now, because it is a mean of a function of the score, we can use our form from above and rewrite this as the variance of the score is equal to 1 over 34 times a sum over the score from 0 to 5 of F score times the square of the difference between score and the mean score. Okay, so now let's calculate that for our case. We take our expression for the variance of the score and we substitute in the values of score and F score from our table, and we remember that the average value of score was 2.88. So we do that for each of the terms in the sum. For example, for the first term in the sum, there were 3 games that had a score of 0. So in that case, F score is 3, score is 0, and again, the mean was 2.88. So we do that for each of the terms in the sum, and we add them up, and we get that the variance is approximately equal to 3.04. Okay, so we have a result for the variance. The variance of the score is about 3.04. Now, the standard deviation sigma is easy to calculate. It's just defined as the square root of the variance. It gives us an idea of how broad a distribution is. So here, it would give us an idea of how different the score of a game typically is from the mean score of 2.88. So here, sigma is equal to the square root of approximately 3.04, so that gives us sigma is approximately 1.74. Okay, now lastly, let's calculate the median. If you take a list of numbers and order them from smallest to largest, the median is the middle number, if there's an odd number of them, or the average of the 2 middle numbers, if there's an even number of them. For example, the median of the numbers 11, 3, 8, 2, and 7 is the middle number of 2, 3, 7, 8, and 11, which is 7. And the median of 9, 11, 2, and 4 is the average of the two middle numbers of 2, 4, 9, and 11, which is the average of 4 and 9, which is 6.5. Okay, so let's calculate the median score. So we order the scores as follows. So there are 3 games in which there was a score of 0, 6 where there was a score of 1, etc. And here the two middle scores are both 3. So the median is the average of 3 and 3, and that gives 3. So both the mean and the median are used to give an idea of the typical value of an entry in a set of numbers, but they are different things. In particular, the mean can be affected a lot by outliers, a few numbers much larger or smaller than the rest. For example, if there had been one game where the team scored 40 points, that would have affected the average, but would have left the median unchanged. Okay, so now let's summarize. So in this video, we've given a quick review of the definitions of the terms mode, mean, variance, standard deviation, and median. These are useful to know for a wide range of contexts. We'll also be using these definitions in some other videos.